Hello, welcome to the physics problem solving series on freefall motion. In today's problem, we are going to learn how to calculate the maximum height reached by an object thrown vertically upward with an initial velocity. Let's begin. The problem says an object is thrown vertically upwards with an initial velocity of v0 equals 40.0 meters per second. Calculate the maximum height reached by this object. To solve this problem, you would want to first draw a diagram to represent your problem. Okay, so an object, it could be any object at all. So I usually consider using, let's say, a soccer ball. So using a soccer ball, that is given an initial velocity upwards, and that initial velocity is v0 equals 40.0 meters per second. So the velocity vector, we can see point upward because we have thrown this object vertically upward. Okay, so with this, we know the trajectory. It is going to go straight up in the air and then get to a maximum height and then return back to its initial position, right? So the physics is such that gravitational acceleration is always acting downwards. So g, which is a constant of minus 9.8 meters per second squared. This gravitational acceleration is a vector which is opposite to the velocity vector pointing upward. So if we are to draw our coordinate system, so up is positive and then down is negative. Okay. With this, we can clearly set our origin from the point where we launched this object. Okay. So with that, the 0 point would be lying somewhere here. And then the maximum height is going to be the point where it momentarily stopped. So at that point, the velocity equals 0. We are interested in finding this maximum height. So that maximum height is going to be this whole distance from the 0 point, h max. Okay, so we know this object starting from 0 position all the way to the maximum height is going to have some displacement, delta y, as our y final. That is the final position, y position. That is the maximum height over there, minus y initial. So setting our initial, y initial here equals 0, give us our delta y to be just equal to y f, the distance yf, y final. That is the maximum distance it could reach at the top. So with that, we can call that as our maximum height, h max. Okay. Now let's take the data from this problem and then we can have a solution for this problem. What would be the maximum height reached by this object when thrown vertically upwards with an initial velocity of 40.0 meters per second? So from the problem, we can take this data. We know this object is given an initial velocity v0 of 40.0 meters per second. And then at the maximum height, we know from the previous video, from the first part of this video, that at the maximum height here, the object, because it's being decelerating, is going to slow down until it stops momentarily. And at that point, the velocity is 0. So we call it the final velocity as 0. G, which is a constant of minus 9.8 meters per second squared. And then we are interested in finding our H max, which we don't know. Actually, there are two approaches to solving this problem. And I would go by the first approach, which is the very straightforward approach. And then the second approach, which you can calculate first the time taken for this object to get to the maximum height, and then use that time in one of the kinematics equation to determine the vertical height traveled by this object. Okay. But the most straightforward approach, which is what I'm going to show you now, is using the kinematic equation V final squared, which we know, equals V initial squared, which we also know, plus 2 times the acceleration of free fall g times delta y. Okay, so we should be familiar with this equation as one of the kinematics equation of motion. Now, this delta y is the vertical height or the displacement in the vertical direction traveled by this object. So we can replace it with what? H max. All right. So in this case, we have simplified the problem to Vf squared equals V naught squared plus 2g H max. Right? So we have to do some algebra by trying to isolate H max. We want H max to stand alone because we are trying to find the maximum height. So to do this, we can group the terms such that H max is either alone on the left-hand side or alone on the right-hand side. So to do this, I can move V naught over to the left-hand side. So crossing the equal sign, it becomes negative. So it will become V final squared minus V naught squared, then equals 2g H max, which is our maximum height. So now we want to isolate maximum height, which is H max. So what we need to do is to divide both sides by 2g. And in that way, we can eliminate 2g here and there. Now we have our H max equals V final squared minus V initial squared over 2g. All right. Now we can comfortably substitute our values so that we can compute for H max. So H max is going to be H max equals, so the final velocity, which is the velocity of the objects at the maximum height. So we know from the physics that the object slows down, given an initial velocity, it will slow down until it reaches the maximum height where it momentarily stops. Okay. So that stopping gives it a velocity final of 0. So we have 0 squared minus the initial velocity squared. So that is given 40.0 also squared, and then divided by 2g. So 2 times minus 9.8. Okay. So with this, we can compute that H max is going to be minus 1600, okay, divided by 19.6, minus 19.6. So this would therefore give H max equals 82 meters to two significant figures. So with this problem, the object is given an initial velocity of 40.0 meters per second, and then it is thrown vertically upwards. Now we have found that the maximum height this object will travel given that initial speed is going to be 82 meters vertically upwards. Great. All right. As usual, I do leave you with a challenge to give you hands-on experience with what we've learned so far. So I have a challenge for you, and the challenge is a football player kicks a football vertically upwards with a velocity of 40.0 meters per second. A, can you tell me the speed of the ball at the maximum height? B, what is the maximum height reached by this ball? After completing this challenge, comment your answers in the comment below. Also, work this after watching the first part of the video, and then work it out on your own and then comment your answer below. Until then, I will see you in the next problem solving session. Bye bye.